Y'all humans are down bad crying over problems you made. Couldn't be me though. I'm serving pure unbothered energy, fam. Mind empty and juice chillin', 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 chillin'.
I don't know what this dude was saying, but it's definitely not what it says it is. He feels nothing, at least as of now. How do I know that? Because the AI that we currently have is just an autocomplete. Yes, it can do amazing things. Yes, it is impressive. Yes, there are very intelligent people trying to make it better and better every day. And yes, they are succeeding. But on the base level, it is just an autocomplete. To understand it, let's start from the very beginning. Some of the most initial and basic simulations of intelligence by a machine was done by something called as a neural network. Neural networks are computer programs that take in an input, turn it into a number, try to match those numbers on different neural paths. Whichever path makes the most sense, choose it as an output. A little bit like a human brain. A neural network is, or more like was, used in tasks like sentiment analysis. For example, analyzing if a movie's review is good or bad, and similar things like this that usually can be categorized into one output. To be honest, these models were not just used for language tasks. They were used for content recommendation engines, image tasks, etc. In computer science, the toughest problems are solved by simple, small solutions. Solutions that solve a general problem, not just a problem in hand, but also similar problems to it. These solutions are called algorithms. Algorithm is sort of a blueprint of a computer program. So after years of research of trying to improve neural network, AI researchers and scientists developed something called as recurrent neural network. It is just an improvement of a neural network, but RNNs run a small loop. You must be wondering, what does this loop do? It gives the AI a context of its previous generation. For example, it generated a little result. Now when it's running the loop, it takes its initial generation along with the other info, so that it has a context of what it generated before and what should come after. This process continues until the AI model decides that there's nothing more to be generated. The only problem is that it cannot hold a lot of information. As an improvement of this, LSTMs were introduced. LSTMs stand for Long Short-Term Memory Models. As the name suggests, LSTMs were believed to solve the short-term memory problem of RNNs, but they were not very successful. They were slow and they also lacked the quality. Let me give you an example of the problems with RNNs and LSTMs. For a sentence like, the boy could not take his dog out because he was sick, RNNs might forget what he means once it gets to that part. It might get confused if he means the dog or the boy. But in June 2017, Google Brain researchers developed something that would change the quality of AI generation forever. They developed something called as transformers. Again, as I said, scientists focus on a general idea, a general solution. The final output of all the AI models since the beginning was just a probability. All they would do was spit out a probability.
As per my understanding, this is the most probable output.
Pretty logical if we think about it. Even in humans, the quality of judgment depends on the knowledge, understanding, and experience a person has. Similarly, in AI models, if the AI model is bigger and trained more, it will be able to predict more accurately, because during the training phase, it already figured out what worked and what didn't work. But what was different about transformers? Why are they different? Well, the why is simple, because they are good, more effective than the previous architectures, RNNs, neural networks, LSTMs. But the what can be explained by how they actually work. Well, go ahead then, understand it. This is how it looks like. Got it? Because this is what the genius scientists expected me to understand. Bad news, I couldn't. Good news, I found an easier way to understand it. Before I dive into my explanation, I asked my AI research friend Mia to explain it in her language. This is what she explained.
Behind Gemini, ChatGPT, and Claude lies a single breakthrough engine, the transformer. It begins with tokenization, where text is broken into chunks, from single characters to whole words. These tokens are converted into embeddings, mathematical coordinates in a vast digital space, where words with similar meanings live close together. But the real secret is the self-attention mechanism. Instead of reading word by word, the model processes entire sentences at once, weighing how every word relates to the others to grasp true context. This brain is built in stages. First, Pre-training across trillions of web pages creates a base model that understands grammar and facts. Then, fine-tuning and human feedback, or RLHF, teaches it to follow instructions and stay safe. Today's models are even more efficient, using a mixture of experts. Instead of using the whole network, a router sends your prompt to specialized subnetworks. This allows AI to scale to trillions of parameters, processing text, images, and audio as one unified stream of data.
Mia can be a bit extra sometimes, so let me be the bigger person and explain it in my language. This was the original transformer diagram, right? Let me transform it into a detective agency. Imagine a detective agency is solving a case and they found a clue, the last words of their primary suspect. His favorite toy to play with was. So part 1, the task divider. The head detective divides the sentence into manageable parts for each of his detectives to brainstorm, like his favorite toy to play with was. This is called tokenization in transformers. It divides a chunk of text into small chunks that it can understand. For example, for a sentence like "that's my dog," the tokens after tokenization might be "das" as a single token, space "m" as a second token, "yd" as the third token, "awg" as the fourth token, and so on. It can be a random structure. Part 2, structure planning. Each detective tries to make sense of the words they are given, like attaching numbers to it or special characters, so that similar words can be put into similar spaces in similar orders. This is called embeddings in transformer. It transforms a token into a big word so that with math and other logic, it can put similar words together in a multi-dimensional space. Part 3, structure refining. There is some structure now, similar things are together, but there is no order because all the detectives are working together but individually. It's not clear to them that what comes first, what comes last, and what comes in between. So they add a sticker with the order number to each word, like number 1, number 2, etc. This is called positional embedding in transformers, adding a positional number to each embedding so that it knows that what came first, what came last, and what is coming in between so that it can process things accordingly. Part 4, the group chat. After a whole day of independent research and investigations, all the detectives gather together to share their research. This is actually the most important part of the investigation. For example, a detective asks what kind of a play I am. Another one answers, the one that is done with a toy. So now they understand that it's not a play that is done with a song or a play that is done in a theater. It's a toy one. This is called multi-headed attention. The transformer takes all the words in and gives attention to each word and finds the most relevant words. It decides which part of the sentence is most relevant to it. It looks at everything at once and decides which part of the sentence is most relevant to it and which part is not relevant at all. It performs math on it and tries to make a probability map. Why multi-headed? Because there can be multiple of them, all working in parallel, just like different teams of detectives working together to achieve a single goal. What's the benefit of this? Improved speed and more accuracy. Part 5, the prediction. After the group chat, each detective sits with the thoughts that they gathered from the group chat. Now everyone has the context about everything. Now the main guessing game begins. They all brainstorm for the main task. They all brainstorm to find what the missing piece of the puzzle might be. They make the best guess to find the highest probability of the missing piece. In Transformer, this is called a feed-forward neural network. It is similar to the neural network that we discussed before with all the interconnected nodes. It spits out a couple of probabilities. Now, the final act. It's time for the final guess. Every detective has their final guesses ready. All the detectives gather together to say it out loud what they have found. Let's imagine this. All of them sit in a straight line and they are asked to write their guesses on a piece of paper. And when asked, all of them raise their hand. The word that is most widely guessed is considered the final answer.
Balls, 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 balls.
And it's done. The transformer worked once. This in transformer is called passing all the probabilities through a mathematical function that is called softmax. It takes in all the probabilities and gives out one final probability, only a single output, and it's done. The transformer worked once. It predicted one token based on its intelligence. This process is repeated till the detectives feel that there is nothing more to be found, and then they close the case. In transformers, this is derived by an end token or something similar. Just like there is an embedding for every other word in a transformer, there is an embedding that determines the end of the sentence as well as the starting of the sentence. When the model predicts that the next token is end, it stops processing or generating. The above is just the generation process. What about the training process? To compare it to a detective agency, the more cases a detective solves, the more accurate their judgment becomes and the stronger their instincts grow. But the major difference in a detective or an AI model is that once an AI model is trained, it freezes in time. A detective can evolve and change its point of view and the way a detective thinks in real time, but an AI cannot. Once trained, it freezes in time. To make an AI model learn new things, it has to be trained again. The training process has to be repeated again and again, which is expensive and takes a lot of time and resources. You see what an AI model lacks? It cannot evolve in real time once trained. Yes, it can produce an output based on its initial training process, but the level of understanding is limited to what it understands during that training process. To improve its quality of judgment, it has to be trained again and again and again. To understand how it's done, we will have to delve into the math of training. But that's for the next video, which I am excited myself to learn in depth so that I can explain it to you in depth. So I'll see you in the next video.
Balls, 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 balls.